Welcome to video 3 for this unit on linear equations, inequalities, and systems. In this video, we're going to focus on rewriting equations. When solving an equation, sometimes we end up with a false equation instead of a solution. Let's look at two examples. 4 times the quantity x plus 1 equals 4x. Here are two attempts to solve it. We start with the original equation. Dividing each side by 4 results in x plus 1 equals x. Subtracting x from each side results in the equation 1 equals 0, which is a false statement. Let's try again, starting with the original equation. 4 times the quantity x plus 1 equals 4. Applying the distributive property to the left side results in 4x plus 4 equals 4x. Subtracting 4x from each side results in the equation 4 equals 0, which is a false statement. Each attempt shows acceptable moves, but the final equation is a false statement. Why is that? When solving an equation, we usually start by assuming that there is at least one value that makes the equation true. The equation 4 times the quantity x plus 1 equals 4x can be interpreted as 4 groups of x plus 1 equals 4 groups of x. There are no values of x that can make this true. For instance, if x equals 10, then x plus 1 equals 11. It's not possible that 4 times 11 is equal to 4 times 10. Because of this, the moves made to solve the equation would not lead to a solution. The equation 4 times the quantity x plus 1 equals 4x has no solutions because no value of x makes the equation true. Let's look at another example. We start with the original equation 2x minus 5 equals the quantity x minus 20 divided by 4. Then, multiply each side by 4 to get 8x minus 20 equals x minus 20. Adding 20 to each side gives the equation 8x equals x. Now divide each side by x to get 8 equals 1. Each step in the process seems acceptable, but the last equation is a false statement. It is not easy to tell from the original equation whether it has a solution. But if we look at the equivalent equation 8x equals x, we can see that 0 could be a solution. When x is 0, we get 8 times 0 equals 0, which is a true statement. What is going on here? The last move in the solving process was division by x. Remember that 0 could be the value of x. Since dividing by 0 gives an undefined number, we don't usually divide by the variable we're solving for. Doing this might make us miss a solution, namely x equals 0. Here is one way to solve the equation once we get to 8x equals x. Subtract x from each side to get 7x equals 0. Then divide each side by 7 to get x equals 0. Let's look at an equation that describes a relationship between quantities. Some ways of describing this relationship are more helpful than others, depending on what we want to find out. Look at the angles of an isosceles triangle, for example. The two angles near the horizontal side have equal measurement in degrees, a. The sum of angles in a triangle is 180 degrees. So the relationship between the angles can be expressed as a plus b equals 180. Suppose we want to find a when b is 20 degrees. Let's substitute 20 for b and solve for a. So a is 80. What if b is 45 degrees? Let's substitute 45 for b and solve for a. So a is 67.5. Notice that when b is given, we did the same calculation repeatedly to find a. We substituted b into the first equation, subtracted b from 180, and then divided the result by 2. Instead of taking these steps over and over, whenever we know b and want to find a, we can rearrange the equation to isolate a. From the original equation, a plus b equals 180, we get 2a plus b equals 180. Subtract b from each side to get 2a equals 180 minus b. Divide each side by 2 to get a equals the quantity 180 minus b divided by 2. This equation is equivalent to the first one. To find a, we can now simply substitute any value of b into this equation and evaluate the expression on the right side. But what if we knew the measurement of b and wanted to determine a instead? Let's suppose that the bottom two angles are 34 degrees each. How many degrees is the top angle? Let's substitute 34 for a and solve the equation. So b equals 112. What if a is 72.5 degrees? Let's substitute 72.5 for a and solve for b. So b equals 35. Instead of taking these steps over and over, whenever we know a and want to find b, we can rearrange the equation to isolate b. We have 2a plus b equals 180. We can subtract 2a from each side to get b equals 180 minus 2a. To solve for a variable, rearrange an equation to isolate one variable. In this example, we have solved for a and solved for b. These are all equivalent equations. Depending on what information we have and what we are interested in, we can choose a particular equation to use. Thank you for watching video 3 of 7 for this unit on linear equations, inequalities, and systems.